Welcome to Alphanumeric Tricks. Today we are going to see problems under first order nonlinear partial differential equations. We already have lots of problems in this topic. We have 9 set of problems previously. Uh, I'll give it in the description box. If you want to check, please go through it. Now we are going to see how to uh, solve the problems of the type p squared plus q squared is equal to z squared into x squared plus y squared. That is type 5 problems. Equations were reducible to standard forms. We have to reduce this equation into standard forms and we have to get the answer. We will see the easiest method for this type. We have to solve already first problem is in the previous video. If you want, you go through it. Now we are going to see the next problem. Solve this p squared plus q squared is equal to z squared into x squared plus y squared. This we have to solve it, and here we have to find the solution. We have to check whether this comes under any of the 5 types. Here we know this is under type 5. Usually you can say that we can reduce this into standard form and we will do it. But in your exams, only one problem is there given, isn't it? So you have to check how to identify this. For that, number this equation is 1. For that, we have to type this. First type is f of pq is equal to 0. That is p and q alone is present in your problem. Here it is not like this. All the variables are present. And here second type. This is second type. Is it the second type? Here all the variables are present here. No, it is not the second type because it is a standard form. Z is equal to px plus qy plus f of p comma q. That is, this is the Clairaut's form. This standard form should be present to apply the second type, and third type is not possible, and fourth type also z is not present but z is there. So definitely this is a type 5 problem. Okay, so this is the way you have to identify the problem. Once you identify, then you get the solution very easily. Now you have to write this. This is of the type equations reducible to standard forms. Okay. After that, you have to do the problems. That is, we have to take this type of problems. Here, z squared is present in this given problem. So you have to take this z squared to the denominator and don't disturb this x squared plus y squared or x squared minus y squared and all present. Don't disturb this. Suppose it is in product, then you have to take this to the denominator of this. That is, you have to take this into left hand side and you have to simplify it. But if it is an addition subtraction, you don't disturb this right hand side term, keep as it is, and the z term is present, that alone you have to take it to the other side. If it is in product, you have to take all the terms. Instead of this, you have a zxy is present in your problem. P squared plus q squared is equal to zxy. In that case, you have to take all the terms to the denominator and simplify it. Okay, but here it is not, don't do like that. Okay, and then after taking that, you have to substitute for p. P is equal to dou z by dou x, and this z is there, and you have to take this all the terms having squared. So you have to take this square term here. Okay, and plus here you have to substitute for q. Q is equal to dou z by dou y, and that is you have to substitute divided by this z. Both are having square, so you have to take that square to the whole terms. Okay, and here x square plus y square is there. You write as it is. Okay, is that clear up to then? Then we pass on to the next step. The next step is you have to take this to the dou x to the denominator of his here, and the dou y to the denominator. So you have z dou y. If you want, you write like this step. Otherwise, you go to next step directly. That is, you have to take this z to the here z to this term, and the z is combined with this z term. And when you taking this, and automatically this dou y comes to down. Or otherwise you have to take like this dou z by z whole thing divided by dou x plus dou z by dou y. The whole square is equal to x squared plus y squared. So you have to get a substitution for this term. Okay, and then After that, you have to substitute this number, this equation as 2. Once you reduce this and you have to go for the substitution, dou x is equal to x. That is, dou small x is replaced by, according to this problem only you have to do it. So dou x is replaced by dou capital X, and dou y is replaced by dou capital Y, and dou z by z. Here, instead of dou z by z, dou z alone is present. You have to take for dou capital Z is equal to dou z. Okay, but here dou z by z is there, so you have to take this whole term to be dou capital Z. So depending upon the problem, or you have to choose this type. Okay, and here we will do number of problems, then you can able to understand easily. Now we will do the next one. Then after that, you have the substitution. You have to integrate it. After substituting this assumption, you have to integrate this one. When you integrating both sides, this integral and this integration differentiation get cancelled, so you have x is equal to x alone. And in the same way, here you have y is equal to y alone, and here integral of dou z, this you have to integrate it, so you have the integration of dou z is equal to integration of 1 by z is log z. That you have to do it, and you have to substitute this in the equation 2. What is our equation 2? This is our equation 2, isn't it? Dou z by az by dou x whole squared plus dou z by z by dou y the whole squared is equal to x squared plus y squared. This is our equation. You have to substitute our assumptions here. Okay, so after substituting this term, whole term is dou z by z is taken as dou capital Z, and dou small x is replaced by dou capital X, and dou z by z is replaced by dou z by dou small y is replaced by dou capital Y is equal to, in the same way you have to do simultaneously the x and y terms also, because x is equal to x and y is equal to y, you have to do it. So x squared plus y squared. Without substituting this also you can do it, but if you do like this, then you feel a little bit easy. Without any confusion, you can change the variables later. Okay, for that only you have to replace this small x is capital X and small y is capital Y. Okay, after that you have to take this and you know that you have to take this capital dou z by dou x is capital P. You know that a small p is equal to dou z by dou x, isn't it? So, and the small q is equal to dou z by dou y. So, but here we have a capital dou z by dou x is there, and dou capital z by dou y is there. So, you have to take the substitution. P is equal to dou capital z by dou x and capital Q is equal to dou z by dou y. And then you have to write this term as it is. After that, you have to number this equation as 3. Okay. Then after that you have to find out the, so this equation is reducible to which type? Third type of equation, isn't it? So x, y, p and q alone is present in your term. So we have to say that it is an equation reducible to standard form. Which type is this? This is separable equation, type 4 problem. This is reduced to type 4 problem. So once you reduced this, and the complete integral, singular integral, general integral are as usual method. Okay, so how will you find out your complete integral then? That is, you have to this separable equations, you write it. So how will you find out this? You have to substitute that term to be, that is, this term is equated to some constant and this is equal to same constant. So we have p square minus x squared is equal to, that is, before going to do this you have to separate the terms, isn't it? So here when you taking this term p squared plus q squared is equal to x squared plus y squared, you have to take the x terms together and y terms together. Okay, so p squared minus x squared is equal to y squared minus, you have to take this q to other side, y squared minus q squared. So you have to take this term to be some constant a squared, because these terms are in square, you have to take this also in square. So p squared minus x squared is equal to y squared minus q squared is equal to some a squared, and you have to equate each is equal to the same constant. So p squared minus x squared is equal to a squared, and y squared minus q squared is equal to a squared. Okay, and then what we had to do next, we had to take this term to be, that is you have to take a p and q terms in the left hand side, and you have to take the other x squared and y squared terms to other side. So p squared is equal to a squared plus x squared. When you're taking this minus x squared this side, it becomes plus x squared, and the q squared is equal to, here you have this q squared, you have to take other side, and when you're taking this plus a squared this side, it becomes minus a squared. So you have y squared minus a squared. This is the term we have. After that, you have to take a square root. Then only you can easily integrate this, isn't it? So p is equal to root of a squared plus x squared plus q is equal to root of y squared minus a squared. This is the term we have to get it. Okay, so what is our complete integral? Next procedure, you have to take this dz is equal to pdx plus qd5. This you have to remember. Equations reducible to standard form, you have to use this one. First problem, second type of problem, all the types you have to use this to find the complete integral. So you have to remember that, and there you have easily using dz is equal to pdx plus qdy. Small things we are using, isn't it? But we change small x to capital X and y, so we have to use this also capital X. Okay, dz is equal to capital pdx plus capital q d capital y. You have to use like this, and p and value are known to us, isn't it? So you have to substitute p is equal to root of a square plus x square, and q is equal to root of y square minus a square. That you have to substitute it. After that, you have to integrate. When you integrating, you have to apply the formula here, integral formula, that is integral dz is equal to integral of root of a square plus x square dx plus the integral root of y square minus a square into dy. So you have to integrate it. You have to apply this formula for integration. You have to remember this formula. Already you have a formula set. You have to refer that, and you have to remember these formulas. Okay, so integration of dz is z, and what about integral root of a square plus x square dx? We have x by 2 into root of a square plus x squared plus a squared by 2 sin h inverse of x by a. This is our formula for this term. Okay, integral root of a square plus x squared dx. Okay, so this is standard formula you have to remember, and one thing you should remember, all the terms you have to take it to be capital X, Y, Z. And then next one, plus integral. Here instead of this, you have a minus a squared is there, so you have little change in this, y by 2 into root of y squared minus a squared. Here you have minus, here also you have minus a squared by 2 cos h inverse y by a plus a constant of integration. You have to use it. So this is the this formula is for this one. Integral of this term is equal to this. Okay, this is your formula. After that, you have to replace this, and our solution is not yet completed. You have to replace your capital X, Y, Z to be small x, y, z. Okay, so what about your capital Z? Capital Z is replaced by log Z, because we are taking dou Z, that is dou Z by Z is the Z we are taking, isn't it? You already get that log Z, so we have to take the substitution here. So Z is equal to log Z plus small x is capital X is replaced by small x by 2 root of a square plus x square plus a square by 2 sin h inverse small x by a plus y small y by 2 into root of small y square minus a square by 2 cos h inverse of small y. This is replaced by small y by a plus a constant. Okay. This is our complete integral. Okay, so this is our complete integral, and we have to number this equation as 4. This, using this complete integral only, we have to find out the singular and general integrals. Okay, so first next we find out singular integral. What is a singular integral? Whenever you have in your complete integral constant term is separately there, then you have to differentiate this equation with respect to that constant term. Then your singular integral becomes very easy when you do like that. Okay. So differentiating 4 partially with respect to this independent variable, that is in this constant c, so because c is separately there. Okay. So when you're differentiating this term you are 0. There is no c term here. So differentiation of this with respect to c becomes 0, because it is taken as a constant, and this term becomes 0 and this term becomes 0. There is no c terms here and only one here except this term. So differentiation of c with respect to c becomes 1, but we get that after differentiating you get 0 is equal to 1, which is an absurd result. This result is not possible. So we conclude that there is no singular integral for this problem. Okay, so this is the way we have to find out the singular integral. If the constant term is not present separately here, you have to differentiate this a and c, and you have to try to eliminate the constants. Okay, and then next one, complete integral. Okay, for a complete integral you have to make use of the substitution that constant c is equal to phi of a, or a is equal to phi of c also you can do it. Okay, because this constant is separately there, no, so it is easy to apply. That's why we take c is equal to phi of a in equation 4. What is our equation 4? That is log z is equal to this one is our equation 4, and here we have to take this term to be c is replaced by phi of a. Okay, so when you're replacing that, log z plus remaining terms are as it is. Okay, all the things you have to substitute as it is, and in the place of c you have to replace phi of a. And here where we doesn't know this constant phi of a, so we can't simplify further. So that's why you have to conclude your answer like this: differentiating this 5 partially with respect to a and eliminating the elimination of arbitrary constants gives the general integral. This is the way you have to conclude your general integral. For all the problems this is the case, because we only substituting c is equal to phi of a, we only taking this function. Okay, constant is equal to some function of some other constant we are taking, so we doesn't know the value of this function. That's why after your substitution you have to write like this: eliminate differentiating this partially with respect to this constant a, because it is reduced to only one constant, no, so you have to differentiate this with respect to this one constant, and after you have to write like this: differentiating this with respect to this constant, and after eliminating the arbitrary constants we can get the general integral. This is the way you have to conclude your result. Okay, that's all for this video. If you have any doubts, please provide in the comment section, and thanks for your time and thanks for watching. Please subscribe our channel for more videos like this. Thank you.